every time something is tested, right? We talk about we're gonna test the hypotheses. In last homework, we came out with the null hypotheses, the alternative hypotheses. Now, every time we test something, every time there's something tested, there are errors, right? Not everything is correct. So today's homework, we're gonna be looking at what we call errors type 1 and errors type 2, okay? Now, some keywords I wanna go over. Remember, feel free to pause the video, rewind it if you need to. Now, I'm gonna go over 3 keywords you guys should be able to write on your notes. There's test statistic, okay? So kind of like it says it. We're gonna test something. Statistics what we're dealing with. Now, this is a numerical value. So it's a number that we're gonna be able to compute from the sample. And this number is gonna be used to decide whether we reject or accept the null hypothesis. Right? We're going to have a null hypothesis. We're going to have an alternative hypothesis. We're going to run a test. There's going to be a number. That number is what we call the test statistic, or the sample statistic that we're going to use to see which of the hypotheses we're going to accept, the null hypothesis or the alternative hypothesis. Now, type 1 error, that one is when we say the null hypothesis is not good. We reject it. We reject the null hypothesis and we go with the alternative hypothesis. However, the null hypothesis was true, right? Like I said, the errors can happen. The type 1 error is when we have the two hypotheses and we say, I accept the alternative hypothesis. I accept the alternative hypothesis, but in reality, the null hypothesis was better. The null hypothesis was true, but I accepted the alternative. That's type 1 error. And this type 1 error, we're going to denote it with alpha. It's a Greek letter called alpha. Let me write that one for you. Alpha looks like this. Okay, now we're going to denote that as alpha. That is the type 1 error. Now the type 2 error, again, I'm looking at the null hypotheses. I'm looking at the alternative hypotheses, but I accept the null hypothesis. I say the null hypothesis is what's better. However, the null hypothesis is not. So type 2 error is when I accept the null hypothesis, but the alternative was even better. Right? That's a mistake. That's what we call it, error. This is type 2 error. Now, the probability of committing a type 2 error, we're going to denote it. We're going to write it with the Greek letter beta. Let me write that out. So beta looks like this. We're gonna be able to work those out. Now, I know we've been looking at the C-score, the table that I gave you for the C-score. We're still going to use that table. I mentioned when I gave you guys a table that we're going to be using it for many, many units. We're still going to use that table for some of our work. So let me flip the page. Let's take a look at some work. I even gave you guys a chart here. Okay, so we have the null hypothesis and we have the alternative hypothesis. Let's say the null hypothesis is true. If I accept it, you guys see here on the top, I said the null hypothesis is true. And here on this side, I said the alternative hypothesis is true. Here at the side, I either accept the null hypothesis or I reject the null hypothesis. When I reject the null hypothesis, basically means I accept the alternative hypothesis. Right? Accept means I accept it. Reject means I take the other one. So if I accept the null hypothesis and the null hypothesis was true, well, I made a correct decision. If I accept the null hypothesis, but the alternative was true, that's what we call the type 2 error, or we call the probability of beta. You guys see my B here for beta. Now, if I reject the null hypothesis and the null hypothesis was true, well, I made an error. That's what we call type 1 error, and we call probability of theta. Do you guys see my Greek letter theta there? And then If I reject the null hypothesis, but the alternative was true, well, I made a correct decision. Some of you will be like, wait a minute, you just said null hypothesis, but the alternative was true. Yeah, I said I reject the null hypothesis. That means I accepted the alternative hypothesis, and it was true. So yeah, I made the correct decision. So here we're gonna read this. That table there is basically for you guys to be able to use. We're gonna look at this. A certain national lunch program mandates that for a high school to receive reimbursement for school lunches, the number of calories served at a lunch must be no more than 810 calories. Suppose that a nutritionist believes that the true mean number of calories served at a lunch at a school in the country exceeds 810 calories. Okay, so we're going to specify the null hypotheses and the alternative hypotheses for this claim. So I'm going to say the null hypotheses. Let me zoom in here. The null hypotheses and the alternative hypotheses. Now they were saying that it has to equal it cannot be more than 810 calories. So if I go to school lunches and they're gonna say, yeah, the high school people are gonna say, yeah, definitely my lunch, it has 810 calories. So the null hypothesis, I'm gonna say in this case, mu is equal to 810. But I'm running a test, right? Someone believes that the true mean of calories served at lunch exceeds 810. Exceeds. What does that mean? Exceeds. That is more than, right? Exceeds is that it's bigger than 810. So the alternative hypothesis, I'm gonna write this as mu is greater than 810. So I have the null hypothesis and I have the alternative hypothesis. Now here it says describe a type 1 error in the words of the problem. Okay, so type 1 error means that I reject the null hypothesis, but it was actually true. So type 1 error, in this case, I'm gonna say the researcher concludes that the mean is greater than 810, but in fact, the mean is not greater than 810. That's what I will write here, okay? The type 1 error means the researcher concludes that the mean is greater than 810, but in fact, the mean is not greater than 810. Now, what is type 2? I'm not going to write it, I'm just going to say it. It says describe a type 2 error. Well, type 2 error, according to my table, I accept the null hypothesis, but in fact, the alternative hypothesis was true. So in this case, I'm going to say a type 2 error means that the researcher concludes that the mean is not greater than 810, because I'm going to accept the null hypothesis, but in fact, the mean is greater than 810. Okay, so not bad. Let's take a look at another example. A study analyzed the sustainability behaviors of CPA corporations. The level support of corporate sustainability measured on a quantitative scale ranging from 0 to 160 points was obtained for each in a sample of 975 senior managers at CPA firms. The CEO of a CPA firm claims that the true mean level support of sustainability is 68. So it's to specify the null and alternative hypothesis for this claim. So I had to come up with a null and an alternative. Keep in mind, the CEO of the firm that I'm studying, CEO is basically the boss, the boss here, claims that the support is 68. So I'm gonna say my null hypothesis. I'm gonna say the mu, the average of these, is equal to 68 because that's what the CEO said. Now my alternative, Well, here I'm not looking whether it's less than 68 or it's more than 68, right? I don't see anything as it exceeds, it's less than or more than. I'm just checking if the null hypothesis is true. So the alternative means that null hypothesis is not true. So in this case, my mu is not equal to 68. See how I did that not equal to? That's an equal sign crossed out. Sometimes people do it like straight. Sometimes people do it sideways. It doesn't really matter. It's just an equal sign that is crossed out. So I'm saying my mu, my alternative hypothesis is that the mu is not 68. Okay, so let's take a look at, for this problem, what is a type 1 error? Remember, type 1 error is when I'm going to reject the null hypothesis, but in reality, it was true. So for this case, using the words here, type 1 error will conclude that the true mean level support is not 68, when in fact, the mean was equal to 68. Remember, I rejected the null hypothesis. That means I accepted the alternative, but in reality, the null hypothesis was true. Okay, now what is type 2? Remember, type 2 is when I accept the null hypothesis, but in reality, the alternative was true. So in this case, I'm going to say the researcher will conclude that the true mean level of support is 68, because I'm accepting the null hypothesis, when in fact, the mean is not 68. Right? I accepted the null hypothesis, but in reality, the alternative was true. Okay, let's take a look at another example. But now in this case, not only we're going to look for the null and alternative hypotheses, but we're going to calculate, we're going to come out with our alpha and beta. And remember, alpha and beta are basically the type 1 error for alpha or the type 2 error for beta. Okay, so let's see. There's intrusion detection system, basically an alarm, is designed to provide an alarm whether unauthorized access to a computer system occurs. The probability of the system giving a false alarm is defined by the symbol alpha. You can see the alpha there, while the probability of a misdetection is defined by the symbol beta. These symbols are used to represent type 1 and type 2 error rates, respectively, in our hypothesis testing scenario. So this alarm system comes over, and what do you think is the null hypothesis? Here, what is the null hypothesis? Well, more likely the alarm wants to sell something, right? What are they going to tell me? That they're good. They are good. So there is no intrusion. They are very good. So my null hypothesis in this case, there is no intrusion. They're claiming to be good. Okay, so what will be the alternative hypothesis? Because they say they're good, but how do I know? Like, what will be the opposite of that? Well, that there is an intrusion, right? So the alternative will be there is at least one. So I'm gonna write an intrusion. So they failed. Now, according to a college research lab, we came and we tested this system. Only 11 in 2,000 computer sessions, there were no intrusions. Okay. So, I mean, with no intrusions resulted in a false alarm. So 11 out of 2,000 computer sessions with no intrusions resulted in a false alarm. Okay, so there was no intrusion. There were 2,000 times that there was no intrusion. So the null hypothesis was true. But 11 of them gave me a false alarm. So we're going to figure out alpha. When probability of alpha? And here, not going to be too difficult. I'm just going to go 11. 11 out of 2,000, right? So how do we do that? I'm just going to go 11 divided by 2,000. Remember, fraction, I wrote it as a fraction, but fraction means division. Now, 11 divided by 2,000. I type it in my calculator, and it gives me 0.0055. Good. I see my answer. It says round to 4 decimal places as needed. Good. I have 4 decimal places, so I'm good. So there you go. My alpha, it gave me false alarms 11 times out of 2,000. So 0.0055. Now, for the same system, the lab found out that 600 of 4,800 intrusions were actually detected. Use this information to estimate the values of alpha and beta. Now, my beta is basically an intrusion, but there was no alarm. So the way I'm going to say it, okay, the way I'm going to do this, 600 out of 4,800 were actually detected. So remember, 600 of 48 were actually detected. So how many were not detected? So I'm just gonna go 4,800 minus 600. That's gonna tell me how many were detected. Now 4,200, right? Because I'm gonna divide this by 4,800 because there were 4,800 intrusions. Now 4,800 divided by 600 is 4,200. Divided by 4,800, according to my calculator, is 0.875. I see my instructions, it says round to 3 decimal places as needed. I have 3 decimal places, so that's good. That's how we figure this out. Let me zoom out so you guys can see what we did.